Hi there, this is the homework tutorial for oxidation numbers and for redox. Earlier in the year, and I think we've reviewed them now, we have some rules for oxidation numbers, so you'll want to refer back to those as we determine oxidation numbers for some of these. Okay, so we'll start with letter B here. What we want to do in this top section is determine the oxidation number of whatever's underlined. So manganese is underlined here. Well, I don't know any rules about manganese, but I do know a rule about oxygen. Oxygen's oxidation number is always -2. Okay, that's an always rule. So -2, and there's 4 oxygens, gives me a total overall negative charge of 8, -8. Okay, so when you see a charge here, that means that the oxidation numbers of the elements in the compound have to sum to this number. So manganese and oxygen has to sum to a -1. Well, I've already got a -8, okay, -8 charges. So in order for this to sum to -1, that would mean that manganese charge has to be a +7. +7 minus 8 sums to -1. So what is the oxidation number for manganese? It's +7. Okay, doesn't look like a 7, but it is. Okay, so let's try that with this one. Okay, so we'll start with the rules that we know. We know that sodium is in group 1, and everything in group 1 always has an oxidation number of +1. So since there's 2 sodiums in this, that means I have +2 charges here. I have +2 from the sodium. Well, oxygen always has an oxidation number of -2. There are 3 oxygens, so -2 times 3 gives me -6. Well, there was no charge on this compound, so this is a neutral compound. The charges have to sum to 0. +2 minus 6 does not equal 0. So what does sulfur have to be in order for all the positive charges to equal negative charges and sum to 0? It has to be a +4, because that would equal +6, which would offset with this -6 to sum to 0. So what is sulfur's oxidation number? In this case, it is +4. Okay, we're going to try hydroxide here, OH. So we know a couple of rules, but this right there tells me this has to sum to -1. I know that oxygen's oxidation number is always -2. Okay? And in most compounds, hydrogen's oxidation number is +1. So does this sum to a -1? It sure does. So oxygen's oxidation number is -2. We'll just put an equals there so it's not confusing. And hydrogen's oxidation number is a +1. All right, the last one we're going to do on this page is SO3. Okay, we know rules about oxygen. We don't know any rules about sulfur. The rule with oxygen, its oxidation number is always -2. There are 3 oxygens, which means that's a total of -6 charges, 6 negative charges. So if this compound has to sum to 0, because there is no charge out here, that means sulfur in this case has to be +6. Sulfur's all over the place. So sulfur's charge is +6. Oxygen's charge is -2. Okay, yeah, I said it was negative, but that's because there's 3 of them. Oxygen's charge is -2, but there's 3 oxygens. That's why the -6 is there. Okay, don't get confused. Okay, so if we turn it over to the back, we're going to hit some redox problems. This first section wants me to answer which of the following are redox reactions. Well, I'm just identifying which ones are redox reactions and which aren't. Here, this is not a redox reaction. Okay, it's not a redox reaction. In order for it to qualify as a redox reaction, there has to be a change of charge. So what I do is I go through and I look at all the charges here. Silver is always +1. Iodine, -1. Lead, in this case, uncriss-cross oxidation numbers, lead would be +2. Nitrate is always -1. So then we check charges on this side. So silver is bonded to nitrate, silver +1, nitrate -1, because there's no subscripts down here which tells me it's plus and -1. Over here, if I uncrisscross oxidation numbers, because lead is a transition metal, lead's +2, iodine still -1. So look, silver didn't change. Iodine did not change. Lead didn't change. Nitrate didn't change. So this is not a redox reaction. All right, letter E here. If we uncrisscross, that would be a +1, that would be a -1. Well, we know that's not true for oxygen. Oxygen's always a -2. In order for this to be a -2, I'd have to multiply it by 2, which means I'd have to multiply mercury by 2 also. So mercury's oxidation number in this compound is +2, and oxygen's is -2. Over here in the product, when you have a single atom by itself, not bonded to anything, it's neutral. Its oxidation number is 0. Same thing when I have a diatomic element. This diatomic element, this diatomic oxygen, has an oxidation number in its free state of 0. So in this case, mercury goes from a +2, gains 2 electrons to become a neutral charge. Oxygen with 2 negative charges loses 2 electrons to become a neutral oxygen. So this is a redox reaction, and that's why. So just real quick, when you're doing your homework, you do not have to do the part that says reducing agent, oxidizing agent. Okay, we don't use those terms anymore, and we just haven't taken them off, so you don't need to do that. So I wrote out oil rig here. I like to use oil rig, and I write it all over my paper when I'm doing redox reactions. It reminds me that oxidation is loss of electrons, and reduction is a gain of electrons. Okay, if I lose electrons, I become positive. If I gain electrons, I become negative. So looking at this reaction, iron plus copper sulfate yields copper plus iron sulfate. This is a single replacement reaction, and iron has replaced copper. So I like to go through and assign all the oxidation numbers. Iron is in its free state, has an oxidation number of 0. Copper, when you uncrisscross oxidation numbers, this is sulfate, and you would uncrisscross, so that would be +1, -1. Well, sulfate is not -1. Sulfate's -2, which means I'd have to multiply both these by 2 to make them correct. So that makes copper having a +2 charge and sulfate having a -2 charge. On the other side in the product, copper's by itself now, and elements in the free state have an oxidation number of 0. Looking at the compound iron sulfate, okay, when it bonded to sulfate, iron bonded as a +2 ion, sulfate -2. Okay, so when we look at the change in electrons, that tells me which one loses and which one gains. Iron, let's see, iron goes from 0 to a +2. If it goes from 0 to a +2, what did it do? Did it lose electrons or gain electrons? It lost electrons. Okay, so that means I like to label it. That's my oxidation. Copper goes from a +2 to a 0. If it's positive and it gets less positive, it gains electrons. So this is my reduction. Copper. This is going to help me answer my questions now that I've got everything labeled. The element being oxidized is iron because there is a loss of 2 electrons. The change in oxidation number is from 0 to +2. The element being reduced is copper because copper gains 2 electrons. Look, it goes from 2 to 0. The change in oxidation number is from a +2 here to a 0 because it gains 2 electrons back. Okay, if you need help, be sure to email or ask a friend or ask a teacher or whatever you need to do. Good luck, kids.